Have you ever stood outside on a clear night, looked up at the sky and thought, just how far does all of this go? You're not alone. Humans have been asking that question for thousands of years. And here's the wild part. Even today, with all our satellites, telescopes, and supercomputers, the honest answer is we don't fully know. But what we do know is mind-bending enough to make your head spin. So today we're going on a journey, starting right here from where you're sitting, all the way to the edge of everything that exists. Let's go. Let's start with something familiar. Earth, our home planet, is about 12,700 kilometers across. That sounds big, and to us it is. But now imagine traveling at the speed of light. Light moves at 300,000 kilometers per second. At that speed, you'd circle the entire Earth 7.5 times in just 1 second. Okay, now let's go further. From Earth to the Moon is about 384,000 kilometers. At the speed of light, that's just 1.3 seconds. From Earth to the Sun, 150 million kilometers. Still, at light speed, 8 minutes and 20 seconds. Now here's where it starts to get weird. From the Sun to the very edge of our solar system, past Pluto, all the way to where the Sun's influence ends, is called the heliopause. Light takes roughly 17 hours to get there. We've only ever sent one human-made object that far, Voyager 1, and it took that little spacecraft 45 years to reach that distance, traveling at 60,000 kilometers per hour, and we've barely even left our own neighborhood. Our sun is just one star among hundreds of billions in the Milky Way galaxy. The Milky Way is a spiral galaxy, shaped like a giant pinwheel, about 100,000 light years across. 1 light year is the distance light travels in an entire year. That's roughly 9.5 trillion kilometers. So the Milky Way is 100,000 times that. Our solar system sits about 26,000 light years from the center of the galaxy, kind of like living in the suburbs, not downtown. Now, just across our own galaxy from one side to the other, light would need 100,000 years. If you tried to drive across it at highway speed, 100 kilometers per hour, it would take you approximately 1 billion years. The universe itself isn't even that old. Awesome. But here's something that should humble every single one of us. The Milky Way, as massive as it is just one galaxy. In 1995, NASA pointed the Hubble Space Telescope at what appeared to be a completely dark patch of sky, a tiny region, about the size of a grain of sand held at arm's length. What came back shocked scientists. That tiny dark patch contained over 3,000 galaxies, each galaxy with hundreds of billions of stars of its own. Scientists now estimate there are roughly 2 trillion galaxies in what we call the observable universe. Not the whole universe, just the part we can see from Earth. The observable universe stretches about 93 billion light years from one side to the other. Wait, 93 billion? But the universe is only 13.8 billion years old. How can it be larger than light could have traveled in that time? Great question, and this is where Einstein comes in. Space itself has been expanding since the Big Bang. Galaxies aren't just moving through space. Space is stretching between them. So the galaxies that emitted the oldest light we can see have since moved much, much farther away. That's why the observable universe is 93 billion light years wide, even though light has only had 13.8 billion years to travel. Mind, officially, blown. Now here's the part that keeps cosmologists up at night. The observable universe, those 93 billion light years, isn't the whole universe. It's just the part whose light has had time to reach us. Beyond that boundary, the universe keeps going, and we genuinely don't know how far. Some models suggest the full universe could be at least 250 times larger than what we can observe. Others suggest it could be infinite, stretching on forever, with no edge, no wall, no end. And if the universe is infinite, then everything that has ever happened, every version of you, every decision you have ever made, is happening again, somewhere out there, an infinite number of times. That's not science fiction. That's a real theoretical possibility called cosmic inflation. We simply cannot know for sure because we can never see past our cosmic horizon. It's like standing on the surface of the Earth and not being able to see beyond the horizon. The world doesn't end there. You just can't see what's beyond it. Let's try to make sense of all this with one final devastating comparison. If you shrunk the entire observable universe down to the size of the Earth, the Milky Way galaxy would be smaller than a single grain of sand. And our solar system within that, it wouldn't even exist on that scale. Here's another way to think about it. The universe contains more stars than there are grains of sand on every beach and desert on Earth, combined. We're talking somewhere around 1 septillion stars. That's a 1 followed by 24 zeros. And yet, in all of that, across all that incomprehensible vastness, we exist on this tiny blue dot. Looking up, Carl Sagan said it best, "The cosmos is within us. We are made of star stuff. We are a way for the cosmos to know itself." So, how big is the universe? At minimum, 93 billion light years across, just the part we can see. Likely hundreds of times larger than that, possibly infinite. And honestly, that uncertainty isn't frustrating, it's beautiful. It means there's still so much left to discover. The next time you look up at the night sky, remember, every single star you see is separated from you by distances so large, our language barely has words for them. And yet, here you are, a tiny collection of atoms on a small planet, understanding all of it. That's pretty extraordinary, don't you think? If this video made you feel something, hit like, share it with someone who loves space, and subscribe for more videos that make the universe feel just a little bit closer. I'll see you in the next one. See you in